Hey, this is John and Ben. Welcome to Artimatic's YouTube channel.
Today, we're going to be talking about the history of OpenAI and a little bit about one of their inventions called Clip. I'm going to start your 5 minutes. You all ready?
I'm ready.
Do it. Start
All
now.
right. So OpenAI, and admittedly, I'm getting some of this stuff off of Wikipedia, but some other places too. I want to get to OpenAI's mission because it's crazy and it's something that I didn't realize until I actually looked into this. But let's go back and talk about sort of the history and the facts first. So I don't know how many people know this, but actually probably a lot of people that follow my other YouTube channel. But Elon Musk is one of the co-founders of OpenAI, and it's only been in existence since December 11th of 2015, so not even 7 years yet. And holy crap, they've done a lot of stuff in 7 years. So anyway, it was founded by Elon Musk and Sam Altman. And Sam Altman is somebody who you might not know as much, but he's actually the founder of Y Combinator, which has started up, I mean, holy mackerel, I think it's like Coinbase, Airbnb, like you name it. They were like the accelerator that did all this stuff, and they started in 2005. So it really wasn't all that long ago that all this stuff happened. So anyway, so these are two really big hotshots, and they gave OpenAI and plus some other investors. But anyway, collectively, they gave OpenAI over $1 billion to start up. So boy, I wish we had that kind of funding, right?
Yeah, nice.
Right. That would be nice. And then even better than that. So they were started as a nonprofit. And this is kind of confusing because there's OpenAI LP and then there's OpenAI Inc. And OpenAI Inc. owns OpenAI LP, and OpenAI Inc. is nonprofit. But OpenAI LP is what's called capped profit, so that they can actually take investments from other companies. And I think what forced that to happen was that Microsoft wanted to invest $1 billion into them in, what was it, 2019. In 2019, Microsoft wanted to invest $1 billion into OpenAI. So they kind of changed things around so that they're sort of for profit. So it's sort of a weird status that they're in. But anyway, I'm going to get to their mission statement and the reason why they're that at this point. They're based in San Francisco, and interestingly enough, they are in the same building, which is the Pioneer Building in San Francisco, which also Neuralink is in, and that's another Elon Musk company. So when people talk about Musk's companies, obviously Tesla and SpaceX, but then also Neuralink and OpenAI and the Boring Company, which is the tunneling thing. So there's a lot of companies that he owns, and you can kind of see this collective vision. And basically, what they wanted to do was to create just get the highest, like the best AI people in the world. And Andre Karpathy, by the way, was at OpenAI before he went to Tesla. So he was one of the so he was one of the super hot shots at OpenAI that then went on to Tesla. But anyway, apparently really like top level AI researchers are paid higher. They said higher than NFL players. So they have really, really high salaries. Apparently OpenAI doesn't quite give them that level, like Google, Facebook level of money, but they give them a lot more freedom. Anyway, so that's some historical stuff. I want to forgive the train. Sorry, there's a train going by, but I really want to get to this, which is, can you see that?
Yep, I can see.
Okay, so this is the crazy thing. This is their mission statement. OpenAI's mission statement is to ensure that artificial general intelligence benefits all of humanity. And artificial general intelligence is the kind of crap that you think about when you think about like Terminator or oh gosh, what are some other, future history movies? But anyway,
Ex Machina.
Yes, Ex Machina. Oh, that's a really good one. That's a terrifying movie. So, but anyway, this is kind of crazy that their mission is that big, and that's what they're trying to do, is to actually ensure that AGI benefits all of humanity. And I want to get here to their charter. That's what I really wanted to talk about, and I have just about 1 minute left. Oh crap. Okay, so basically they want to do this, and they said also if somebody else is beating them, they will then turn around and help that other group of people. So the idea is to direct AI to become as friendly and nice to humanity as possible. They commit to deployment of all of their stuff. Their primary fiduciary duty is to humanity, which I think is really cool. They're committed to doing the research required to make AGI safe and to drive the broad adoption. And then, what they say is in order to have effective leadership, they can't just try to set policy. They actually have to be in the forefront of creating AGI, and that they'll cooperate with other people. And in the last 20 seconds, I just wanted to say, if you know Elon Musk and all of his companies and their mission statements, you can see how OpenAI actually is part of this vision of creating a future that's good and makes people optimistic. And so I think that's really, really cool. I had no idea until I started looking into this that was their mission statement, but I think that's amazing. And that's 5 minutes, right?
Yep, that's 5 minutes.
There we go. All right. So what do you have to say about that? That was a lot of information like dumped at you real quick.
Yeah. Well, actually the company structuring makes a lot of sense, because there are some things that they're just releasing absolutely to the public for free, open sourcing it, like Clip, which I'm about to talk about. But then they have other things like dall-e, which is an image generator, which is actually they kind of keep it behind a paywall and host it on their sites. So I'm sure there's a lot of corporate structuring stuff around those decisions.
Well, it was, I didn't get into it because I ran out of time, but of course, they developed GPT, GPT-2, GPT-3. They're now working on GPT-4, which is generative pre-trained transformer. Yeah. But anyway, that's the gigantic model that sort of broke the internet and changed things around for the better. But when they produced GPT-2, even though their mission is to share all of their stuff, they said that they wouldn't actually share the model because they were trying to be careful about releasing it to everybody, because they were worried that some bad players would be involved. And so I think that's part of the argument for dall-e 2 as well. So yeah.
Makes sense. I think there's also there might be a financial incentive to keeping it closed, but yeah, that does. There's a lot you can generate. I mean, there's a lot of things you wouldn't want mass generated, but that's a whole nother ethics debate.
Yeah, that's a huge thing. And it is interesting that there was this division because they were definitely not for profit until 2019 when Microsoft wanted to invest $1 billion. But now they are kind of for profit. And so I think that, now it's like, well, wait a second, if we release all of this stuff, then how do we make any more money? So, so I think they do have some financial motivation. And I actually have talked about that before in another video about how dall-e 2 is kind of like a flywheel, because you have humans interacting with it, giving input and saying, this is what I want, and then clicking the ones that they like. And then that gives an indication to the AI which ones human beings think are like the best produced product for that input. And then they can use that to generate more data so they can actually create a commercial flywheel. And people are paying $15 a month for it. So there you go. So
yeah, then they keep a hold on that data that they're creating through this flywheel.
Right.
So yeah.
So pretty classic. It's interesting because a lot of people don't think about Elon Musk as involved in OpenAI as much, but he did quit the board before Microsoft invested because he said it would be a conflict of interests with Tesla, I think. So anyway, so he's just a donor at this point, and I'm sure has some stock or whatever the equivalent is in the company, but kind of hands off.
It's certainly not a publicly traded company.
No, but I'm sure there's also some sort of private. I mean, if you invest $1 billion,
it's not an LLC.
Yeah, exactly. So, yeah, interesting.
That is very interesting. Was there anything else you wanted to say about the AGI stuff?
I just found it interesting because I thought, their mission statement would be something like, "Hey, we want to create the coolest toys and the best artificial intelligence," but to talk about specifically general intelligence, that's, up until narrow AI, like what we're going to talk about with Clip next is pretty, it's really amazing what it does. And it's better than human beings, but it's not a replacement for a human being. And AGI kind of trends into that realm of this thing understands itself and it knows what it is. And it's like a conscious being. And so I didn't realize that their mission was quite that it's a pretty darn big mission, but again, it makes sense for Elon Musk because he's that kind of guy, he's like life 2.0 on Mars and making the whole world electric with Tesla. So it makes sense that you would have that kind of ridiculously large vision.
Yeah, I think it also makes sense why they tend to do these big projects that are kind of part of the human experience, like
Right.
image understanding and text synthesis, those kinds of things that are part of AGI that you have to build
Right.
together and figure out how they're going to work together, rather than doing something a little more specific, like what we're doing at Artimatic.
Yeah, that's
very
true.
commercialized AI, very specific things for a specific group of people.
Right. And I mean, certainly GPT just started off as a research paper. I think it was not that long ago. It was 2018 with GPT-1, which was, the original research paper for it. So I think they're just like, they're pure research. Right? They just try stuff and maybe it'll work and maybe it won't, but because they're such smart people, oftentimes I think it works. So but then they've got this kind of interesting little commercializing angle that they've added to the whole thing.
That'd be interesting to know, like how many different things they're trying and kind of failing at compared to the things that are really succeeding. Because I'm sure just the pure genius of the people that they're hiring, I'm sure they have tons of good ideas every day, but you only hear about a few of them.
Right. Yeah, that could be true. And who knows what's cooking right now that could come out in a year or two.
Yeah. So, or 10 years.
Yeah, exactly. That's actually true. I mean, they may have people who are like really smart and have ideas, but they're just not possible yet because they're so advanced. So interestingly enough, I think as of 2021, they only had 120 employees. So it's not a big company at all.
Oh, no, not at all.
So I would imagine, probably given Elon Musk's sort of bent, it's probably like 80% of those people are actually active AI researchers and 20% are like support. So
yeah, that makes sense.
Yeah. So anyway, I mean, that could be like 100 of the best AI researchers in the world. That's a pretty good, I guess a football team's a good comparison because there's usually like 60 or 80 like players who are part of the team. And so that's something.
Yeah. Yeah. You got your managers and people that are taking leads on different projects.
Right.
Which I guess the football analogy falls short there, but
right. Yeah, that's true. There's no coach. Oh, by the way, Sam Altman, the Y Combinator guy, is the CEO of OpenAI. So, he has not taken a hands-off approach. He is fully invested. So
he has some good YouTube videos if anyone's interested. Sam Altman, and I think he interviewed Elon Musk one time. He's just a really intelligent guy.
Yeah. Okay. I'll have to check those out. That's cool. So speaking of all this stuff, CLIP, which is, if it's an acronym for something, I can't remember, but anyway, it's a image to like text sort of processor. So if you think about typing in text and getting an image, this is the inverse of that, right? This actually takes an image and gets text out of it. Is that correct? All right. Well, all right, let's give you 5 minutes and you tell me all about
Start the clock up.
All right, let's start the clock. You ready? Okay, here we go. 3, 2, 1, go.
All right. So CLIP stands for Contrastive Language Image Pre-training, but
they always have to have pre-training in there.
It's a good sounding acronym, but the jumble of words is too much there. What it really does on the surface is connects text to images. It tells you the similarity between some images and text. It doesn't necessarily generate the text for you, but from an image and a group of texts, like a set of input text, it can tell you the most similar, the prediction of similarity between all of these. So you can see with this picture of a dog, it knows it's a King Charles Spaniel compared to a Cocker Spaniel, which is
so in other words, it's better than me.
yeah, exactly. That's pretty incredible. Black-chinned hummingbird. It wasn't perfect at this one, but they were pretty honest in their research, showing just randomly chosen results, which is pretty noble. So what it does is it takes an image and encodes it, which is basically smashing it down into just some numbers. I might talk about encoding in another video because that's a whole thing on its own. And it does the same with a group of text. It tokenizes them into numeric values and then puts them into an encoding that the machine can actually learn. And then it creates this similarity matrix to tell you which combination is the most similar. It's trained using a set of pre-trained image to text pairs, and I think it was 400 million text to image pairs for the data set. So it'll randomly pick out maybe like 256 images and their text pairs that was pre-made, pre-assigned. And then it attempts to, it creates this matrix where it attempts to improve the similarity between the input image and its text and reduce the similarity of that image to every other text. Is that, you following me so far?
I think so. So does it, like, can it cheat? It actually knows ahead of time what the right answer is in these while it's training.
That's the image to text data training. Yeah. So the loss value would know, but
right.
The optimizer would know. So once you have this trained clip model, you can take something like a huge set of text and an image, and you can say which one of these texts is closest to these image. So you can imagine this could be like 1,000 different words over there: plane, car, dog, train, house, and it will come up with the text that's most similar to that input image. All right, so you might be wondering, like, how is this different than just your typical classification, like image classification algorithm? So CLIP is a whole lot more flexible. You don't need to know your categories ahead of time. It can tokenize really any text phrase to a certain extent. Like, it couldn't. I think it's like a paragraph. You can imagine that it can turn that into an encoding.
30
which
seconds,
is,
by the way.
Oh man, I'm not going to make it.
We can cheat and give you a little extra time.
All right. So it's very flexible is the big thing. I'm going to go through why I think it's super cool. First, it's open source, so anybody can use it, and that was awesome of OpenAI to do. So there's quite a few other algorithms that are relying on it right now that we're seeing come out in real time. Okay, that's my time. But
there's your time.
Two more cool items.
Let me ask you, can you tell me more about this?
Oh yeah, there we go. The second cool thing is that it's just super good at captioning. Like we haven't seen before. It's probably the best captioning tool, going from image to a caption, descriptive caption that I'm aware of. So you could imagine, I'm not sure what it's called, but I think like blind people have those devices that help them decipher what things in the physical world are.
Right.
So you could put something like that on a computer so they could hover over an image that doesn't have the alt text attached to it and just be able to say, like, here's an image, convert it to text immediately. Obviously, it's not perfect right now. The third really cool thing about this is it works super well on captions that it has not seen before. You could give it something completely new that no one has ever thought of before, like a raccoon wearing a top hat, smoking a cigar. And
you know that's going to end up getting overlaid over this right now because I'm going to have to go search on dall-e.
Yeah. There's the thumbnail for the video.
Exactly.
You can give it something that it's never seen before, but it has an ability to reason from breaking apart this text into its different encoding pieces, and then looking at similarities of maybe even new images that it's never seen before.
Wow.
I'm going to be referring back to Clip a lot in future videos.
Yeah. We're going to sort of build these things up, I think. So that's actually cool. So I don't know. Do you want to stop sharing screen and we could continue talking about it? Because I have some questions about this.
Okay.
Cool.
Let's see if I can answer them.
Well, yeah. I mean, the first one is, so I think for a lot of people who might not understand they might think like, okay, this is just like a convolutional neural network that does classification. But the way that that's structured is that like the ImageNet thing has 1,000 categories, and each category, I think, is just a word. But I mean, it's a number associated, but it's just a simple thing like dog, cat, whatever. This is able to tokenize and understand, like you said, like several words, a sentence, paragraph, like a lot of text. So it's much more capable than a traditional convolutional neural network. I think the part that I'm still confused about is when you give it these image text pairs, are those pairs that, like, there's an image of like the King Spaniel or whatever that thing was, but that's like somebody actually wrote the text of that down.
Yeah, so that's pulled from ImageNet's massive data set of already captioned images. Yeah,
somebody had to caption 400 million images. That's insane.
ImageNet is a beast of its own.
Right.
There's probably a pretty good story there.
Yeah,
we might have to do some research on that and how they actually accomplish that, because it's an incredible data set of already captioned images.
Wow.
I'm not quite sure all that they used, but yeah, it's all pre-captioned images, and a variety of them too. And I think people are continuing to fine-tune Clip with their own data sets. I want to say the stable transformers, stable diffusion, sorry, one of the newest models that has come out with Clip. I think they used Pinterest for a lot of their training.
Interesting. Okay.
Yeah.
That's very cool. Because people generally tend to like put something underneath like a label.
Yeah. And just the Pinterest board is a bunch of images with little titles that are descriptive.
So, wow. I think part of what blows my mind is not just how cool all this technology is, but the fact that we have access to 400 million image text pairs. That's ridiculous.
Yeah.
It's crazy.
Yeah. And they found a way to make use of that, because there's a whole lot of data out there on the internet that is mostly unusable for training AI. Right. And up until now, with some of these newer models, we couldn't use these image to text pairs because they weren't perfect enough. Like you said, with a typical convolutional layer or convolutional network, it might have just had 1,000 or 10,000 outputs. Right. And those 10,000 outputs were like, output 1, what's the likelihood that this is a car? It wasn't a photo of a car. It wasn't a photo in vintage black and white of a it was very specifically a car. Right. But with this embedding, it really expanded how we could use this data.
Yeah, I think that's the biggest thing. Even if people don't understand exactly how convolutional neural networks and stuff work, they were super cool. I mean, it's just still so awesome that you could take a black and white photo or a color photo or the car in a parking garage or the car at an auto show, and it still knows it's a car. I mean, that is really cool. But this is so much more specific, because it's like, I want a red car in a parking garage at night, and it will, find that thing, or it will, or it will generate the clip or the text that will say that if you show it a picture of it in this case. So yeah, it's pretty. So I imagine at this point that they're probably able to do a lot of bootstrapping to create more labels. Because, now that you've got something that works pretty well, I can imagine that you can give it pictures that don't have labels, and it hopefully is labeling them decently well.
Yeah, you can make more image to text labels of your own, right, which might be what they're doing with dall-e on some form. Is when people generate images on their site, people choose which are the best images that I like the most that fit this prompt. OpenAI could mark that, set it aside as an image text pair to train on in the future.
Right. Yeah, that was kind of what my imagination was. I was like, look at this flywheel they're creating.
Yeah.
They've got us, all us stupid humans are like, oh, let's do this. And we're just feeding it more and more data. So
yeah, no, I think you're totally right. I just think the clip stuff grounds it a little bit more in this very specific example of doing that.
Yeah, that's really cool that they can do a image embedding and a word embedding, and they can just smash it. So like for the stuff that they give it for training, they have the correct label, like the text that went with it, and then they just give it a random assortment of some 200, what'd you say, 256 other, I guess they just pull random labels from other stuff.
Yeah, well, I think so the top row was all of the image embeddings.
Okay.
And the left row was all of the text embeddings. And then your first image and your first text will match up, and you want that high similar. I think image 2, text 2, you'll want those to be the most similar. Image 3, text 3, and that's where that.
Oh, so the diagonal. Okay, so you're training in a batch, so you might get like 256 of these image pairs at a time. But then what it wants to do is like all of so image 1, text 2 should be dissimilar. So it also needs to learn to reject that possibility.
Yeah. So it ends up with this pretty cool loss function of increasing similarity of certain items, but decreasing similarity of other items, which makes it train a whole lot better.
Yeah. Have you dug into the math of it, like how they're actually structuring the loss function?
No, I couldn't tell you.
So the model itself is available, or the actual code to generate the model, so you could like retrain it yourself?
Oh, I think it's all available.
Oh, it's all okay. Wow, so it really is open source. Wow, that's super cool.
Although you need a pretty intense computer to train it.
Yeah, I was looking at so GPT-3, if I remember, is 174 billion parameters, and dall-e 1, I don't know what dall-e 2 is, but dall-e 1 was a 12 billion parameter, like mini version of GPT-3. So I assume dall-e 2 is some bigger subset of GPT-3. So
I'd imagine.
Yeah. So interesting.
Parameters.
Yeah. But it takes more than a home computer to run this stuff on.
I got it running on my local machine, but I got it running with batch sizes of about 4.
Right.
So 4 images compared to 4 text, and it works, but there's only so much the machine can learn compared to I said 256, for example, but it could have been like 1,000 images and 1,000 text pairs. And there's just a whole lot more that the computer can learn per batch with that much more choice involved.
Well, we need to fire up all those Amazon AWS stuff and try to do macro batches instead. Yeah, there's actually some stuff on the Wikipedia page about how many. I think they had to rent Google's. Oh gosh, I don't know if I'll find it like online, but they had to rent like Google's one of their entire clusters for like a month to do GPT-3 training. It was something outrageous like that, I think. So anyway.
Okay. Yeah. I see where their billion-dollar investments going.
Yeah. I mean, I think it was over $5 million to train it. And that was the successful run. I think they also did a bunch of trial runs before that. So, it's like, you got to think, before you get to the one that actually worked, they probably had like 100 that didn't. So they probably spent way more than $5 million trying to get it to work before they got it to work. So
yeah, that and the man hours involved.
Oh gosh.
Yeah.
Anyway, pretty cool stuff. All
Mhm.
right. So I guess that sounds good. We've talked a lot longer than 5 minutes on this stuff, but this is super interesting stuff.
Mhm.
I hopefully folks will have questions in the comments for us to answer, or if there's a piece of this like you totally don't understand and you're like, what the hell was that? By all means ask, because we can totally do, an episode on that specifically. That's the beauty of YouTube, is that we can be responsive to this and actually kind of recast it in what you're interested in. So,
and check out our blog on artimatic.io. We can go into a good bit more detail with
right.
writing. We can be more precise there.
Right.
So some of those bigger content.
So by all means, ask away. And thank you for watching. And I don't know, let us know what you think.
Oh yeah, like and subscribe.
There you go. Definitely. Oh, thank you. Like and always, like, you would not believe how important it is, because speaking of AI, YouTube's AI is like all about the liking and the subscribing. So all right. It's one of the things when you research this area, it's kind of weird. It's so meta, because you're like, oh, it's like, I know exactly what YouTube's algorithm is doing under the hood. It's like, these people are paying attention to this stuff. So there you go. Anyway, all right, cool. Yeah, thank you so much for watching, and everybody have a good day. We'll see you later. Bye-bye.
Bye.